Development Program and the role of Big Data and Cloud in the era of transformation. A warm welcome to today's resource person, Dr. D.Sumathi ma'am. Thank you for accepting our invitation, ma'am. Now I request to Jessica to introduce today's resource person.
Dr. D.Sumathi ma'am is presently working as a professor grade 1 scope at Vellore Institute of Technology, VIT, Andhra Pradesh. Ma'am received the BE Computer Science and Engineering degree from Bharatiya University in 1994 and ME Computer Science and Engineering degree from Satyabama University in 2006, Chennai. Ma'am completed her doctorate degree in Anna University, Chennai. Ma'am has overall experience of 23 years, out of which 6 years in industry, 17 years in teaching field. She has an additional responsibility of serving as an assistant director of software development cell, which automates the various functionalities of campus upkeep. Ma'am has taken various administrative roles during her tenure. Her research interests include cloud computing, network security, data mining, natural language processing is the theoretical foundations of computer science. Ma'am has published papers in international journals and conferences. She has organized many international conferences and also acted as technical chair and tutorial presenter. Ma'am is a light member of ISTE, Indian Society of Technical Education. Additionally, Ma'am has published book chapters in CRC Press, Springer, IET Institute of Engineering and Technology, and edited books in CRC. Ma'am is guiding and research scholars under research areas in biomedical applications. Thank you, ma'am.
Sumathi ma'am, I request you take over the session, ma'am.
Yeah, thank you. Let me share my screen. Yeah, hope my screen is visible. Is it visible? Is it visible?
Ma'am?
Yeah, is
You're
my screen
audible, ma'am.
visible?
Yes, ma'am. The screen is visible, ma'am.
Okay. Yeah, thank you. So, like you are in the second day of this FDP, and we are going to see how this big data and cloud computing is transforming the current world. So, as you all know, like a big data means from the name implies it is going to focus on huge amount of data. The data could be both structured or unstructured as well as semi-structured data where huge data is being generated day by day. Suppose if you are working or if you are right now the world is moving towards a 6G and UAV vehicles are being implanted, vehicle communication is being established. For example, if you take any Tesla vehicle, you can see that per day around some 6 TB data is being exchanged over the scenarios. So here we are saying the process of gathering and storing the data as well as analysis of the data is required. So when anyone talks about big data, you can easily remember about this V's. Slowly now, as from the initial stage, it was 4 V's, 6 V's. Now it has gone to 10 V's. You can say velocity, veracity, value, then variety, volume, variability, etc. So variety of data, it could be any kind of data. Either it can be structured or semi-structured or it could be unstructured. What is volume? It could be from various sources. You might be working on mobile, you might be working on platform, you might be working on any other device and data might be traveling from one, not only from one source. speed of the data, how it is being generated, and veracity, how far the data is being a trusted one. So we have so many V's which are constituting to this big data. Over the time we have various descriptions and V's also has been increased. Now talking about the big data analytics tool, Tableau is excuse me, Tableau is there, Cloudera is there, Teradata, R programming. You might have seen R programming. You might have worked for implementing machine learning models or statistics, etc. Spark is there, where we call it as a big data, using for big data. And here we have visualization tools such as Tableau. We have Lumify, Talent, so many are there. Okay, so now how we are going to integrate, why we are talking about big data and cloud, why, what is the necessity of cloud here. Usually in good olden days we had big huge, but now what you are trying, LCD display is coming, LED display is coming, your monitor size is becoming huge and huge, and computing power, storage power is also more and more. But instead of increasing instead of going and purchasing so many hardware devices, what we can do is you can pay and use it. So for that case we are going for this cloud computing. So here, big data, if we want to work on this big data, we require certain pre-processing techniques in order to convert this raw data into a processed data, that is, which will be available for analysis. You cannot go with the raw data. So the data has to be processed. And when we talk about cloud computing, we say that processing could be done parallelly, where you can have the scalability, accessing any kind of data, providing security to the data, virtualization of resources. So, what is this virtualization of resources? You can use any resource whenever you require, and storage of data. Like you, people might be uploading your pictures, albums, data onto the cloud drive, and whenever you want, you will be accessing it. And this cloud computing, using this cloud computing, we are eliminating the investment cost in the case of infrastructure, with the help of paying and using the facilities which we require. Either it can be building a data center. Suppose if your campus is growing huge and you want to provide, you want to develop a software where automation, complete automation is being done. So huge data might be generating day by day. So what you can do is you can build a virtualization data center, where you can you can put all your automated software onto the data center, and you can use data, you can provide the data onto the cloud storage, and whenever you want you can access it. That is one way. So here, this infrastructure scaling could be provided, or it could be done based on the demand. So suppose on one day, so when you're releasing the result, that day server hitting might be huge, but on other days hitting the server might be very less. So based on the fluctuation of the workloads, scalability could be managed. Here you can say cloud virtualization could be able to deploy a virtual platform for devices as well as the operating systems, so that parallel processing could be done. Here the resources could be shared in order to access, analyze the data, manage the data, as well as computation also could be done. Now I'm on my screen, I have a integration of cloud computing in big data analytics. So input could be of data. Any kind of data could be there. So it could be semi-structured, structured, and unstructured data. So using this data, you are extracting, transforming, and learning. This process is being done. So once if you extract, transform and learn, what you will learn, what you will use it. Here, this is the ETL. What I have mentioned here, it is a basic component in data warehousing as well as in business intelligence. So here, this extract, what does this do is, it could be from various sources. Data could be from various resources that is being extracted. Then it will be undergoing various transformations based on the requirements. Like it can be filtering the data, joining data from various tables, or it could be any calculations. It might undergo some calculations also. The last one is loading. Here, after learning something, you need to load the data. So the transformed data will be loaded onto the data warehouse. So this is how uh, it plays this ETL process plays a vital role in preparing the data for analysis as well as reporting. So after doing this, here we can say how the data is being processed using Hadoop, MapReduce, or RDBMS, or it can be NoSQL process. Then later, it is being dispatched or stored in the form of Hadoop distributed file system or Google file storage, where cloud computing comes into the picture. So here providers could be either IaaS, PaaS, or SaaS also. Infrastructure as a service, software as a service, platform as a service. What you can provide a GPU also as a service, CPU also as a service, memory as a service. So what does it do? It does the result and visualization is projected onto the client interface. This is how the integration of the cloud is done in big data analytics. So why we are saying cloud computing will be a natural fit for big data analytics. Why we are saying that? So you can see there are many reasons for saying the cloud will be a best fit, good fit for big data analytics. Scalability. So what does it do? See, as I told you, when there is a demand, we will be using the resources. When there is no demand, we will be just shutting off the resources. So based on the demand, you can scale the resources as well as scale up as well as down the resources. So that is one reason you can adopt this cloud computing. Next is cost efficiency. So once if you use the resources, you will be paying for the resources. So this could be very beneficial in order to handle the workloads that are being associated with the data analytics. Then what about accessibility and collaboration? We have various tools like analytic tools which could be working on the data with an net connection, so that the data could be accessed and it could be collaborated with various other users if required. And advanced analytical tools are there, analytic tools are there where it could establish visualization techniques. Using that, you can provide some analysis on the data. And finally, the data storage is there. So you can store the data and you can access it whenever it is required. So huge amount of data maintenance is quite difficult. So what we are doing, you can when it is onto the cloud whenever it is required, and at the same time security is also quite a matter which we need to focus on. So these are the reasons why we can adopt cloud computing for big data analytics. So, what all the applications? If anyone wants to do research, you can take any of the sector. Either it can be healthcare, or it can be banking sector, or it can be agriculture, airline management system, where huge data will be flourishing onto the field, and you can take any use cases and you can work on that. What are the challenges and considerations while adopting this onto the big data? So, as I told you, the first one is data security. how far the provider can give security or give assurance to our security, and what will happen to the data privacy. So that is one challenge we need to consider. Then, as if you're going to build a virtualized data center, so what will be the challenges during the data which will be hosted onto the cloud? How about the privacy to the data, and how about security will be? So, what agreement, what kind of agreement will be established between the user or the client and the provider? Second one is latency. So, what is the response time? How it is being the data once if it is requested, how it is being accessed, and how it is displayed. That is much more important in the case of data transferring. So that is we need to check on with the cloud provider. Then you can say that if there are number of process in a, because here from the initial step how it is being handled, what is the response time it is taking. And when it comes to this vendor lock-in, we call this as vendor lock-in. So all in one shop at a time. That is what we used to do. Nowadays, people are becoming lazy. So what they do is they'll walk into a shop, whatever they want, they can purchase at all in one. But previously, it was not like that. Likewise, these providers uh, have a concept called vendor lock-in, where they'll be providing all kinds of services at one stretch, but where people might be tagged in, where it might be very difficult to move on to the other uh, vendors or other cloud providers if there is any problem. If there is any problem in the case of storage or customer relation management, then it is quite difficult, because we are dependent on all services for on single cloud. But if you go with multi-cloud, even if one fails, you can just take out. But here, this is not the scenario. So here integration and compatibility as well as a data and format dependencies will be there. Contract, everything matters. So that is why we should be very careful when moving on to or when going for data migration onto the cloud. Then the last one is compliance and requirements. What kind of compliance, what kind of policies they are maintaining, how about transparency, rules and regulations. These are the challenges and considerations when we are going to adopt cloud computing for a big data analytics. So next, we will see as we are talking about ML model. Usually, what happens? Data should be analyzed. So for data analysis, you can deploy a ML model. But what if yeah, I want to deploy an ML model for a big data? So if it is a big data, what we can do is data might be posted onto the cloud. You can develop a model on your local system. Then you can deploy this ML model onto the cloud and you can run it. So the steps which are used for deploying an ML model onto the cloud is, the first one is you need to train the ML model on your local system. This is the first step. Then second step is whatever the logic, inference logic which you are being adapted, here it should be covered up into a Flask application. It should be written onto a Flask application. Then you need to Docker, that is containerize the Flask. You should develop this. Fourth one, as soon as this Docker is created, you are going to host this Docker container on AWS EC2 instance. Then finally, this web service, once it is on, you can consume the web service. This is the workflow for deploying a ML model onto the cloud. So how this will be done? Any ML model, first you can train. So what you can do is you can construct any ML model. For example, you can take any logistic regression, or it can be linear regression or support vector machine, whatever it is. After training the model, you are supposed to save the model. So here, let us assume I have deployed a logistic regression model on social network data analysis. So what the social network data analysis does is, there might be features such as age, gender, and estimated salary. So based on these features, I'm trying to predict whether the user will purchase or not. This is the ML model which we are trying to deploy on a local system. So here, this is the first step. Assume we have developed a logistic regression, and we are working on social network data analysis. So we have developed a model, deployed a model. Next, what inference logic should be written? So here, you can use Flask, which is considered to be a micro web server framework. This is used to build a REST API based web services, so that it will have very less difficulty, or it will be very simple or minimum configuration. So what we do is, this model which we have developed, it could be provided as a REST web service. So how it could be done? Pickle is a library, import pickle. NumPy is a library, and here we have an alias. From the Flask, you need to import Flask and request. As of now, model is none. Here, this model is none. So now we are, whatever the model which we are going to create will be passed on to this variable app. So next, what we are trying to do is, you are going to load the model. There is a function where we are loading the model. Here, this global model, whatever the model you have deployed, that will be identified as a global variable. We will see why this has been given as a global later. So what we are trying to do here, once the model, as I told you, once the model is here, once the model has been trained, you're supposed to save the model. So how to save the model is, in .pkl file, you can save it. So what you can do is, this should be opened in read binary mode. Read binary mode, and here you are trying to load the parameters of that model onto the uh, uh, variable called model. Next here, we need to check whether it is working or not. So we are creating like a hello message. This is a simple hello world message. So next, what we are trying to do is, here, once if it is working, then you can check whether our model is working. It means whether our model is predicting for the new incoming data. So what we have done here, predict. So why we are going for this predict? You are supposed to check for a incoming data. So this post is a request. What we are doing here, you are getting the data as a which has been posted as a JSON file. So here, what all the features we are considering: age, gender, and other one is estimated salary. So we are trying to convert the shape of the data. So once if it is done, it is trying to predict. So here, model dot predict of data. So the model which we have developed here globally will be working on to the new data point which we are trying to give here. So this app, once if it is done, app will be running. So here you will go to the browser, and you will hit the URL, 8 is the port number in order to get a message hello world. Once if this is successful, now what you can do is you can run the command in the terminal in order to query the Flask server. So here this message will be posted. Then on this port number, predict option is being given. For this predict, what kind of content which has been the data will be in JSON format. So what is the data? So age we have given here. So age, gender, and other one is salary, estimated salary. So here we have given gender is one, age and estimated salary. For this, what will be the output, whether the person will be purchasing or not, that should be given. So once that is done, then what we need to do, you're supposed to use a Docker. So but before that, what is a Docker, you should know. Like here this Docker is used to containerize the Flask service. See, what you can do is, as you all know about virtual machine concept, that is the whole operating system, whatever it is, it could be imported as an image, and you can download that image and you can install it. Likewise, here you can create a container based using this Docker, where here the container is for the deploying the Flask service. So this web service should run. This web service is nothing but a ML model which is to be run on a cloud virtual machine. So the cloud virtual machine itself will be running on any OS. It can be any operating system. So why here any issues, whatever it is related to the environment, so that could be prevented based on this containerization. Using this containerization, you can avoid any issues. And for example, if the container is working on a machine, suppose if machine A is there, if your container is working on a machine, in other machine also it will run. So here what happens? Because that container itself will be like an image. So machine A is there. So if machine A is there, I am just having an image where I can, if this is working on machine A, definitely the same image will be working on machine B. This image is considered to be the container over here. So here Docker, which we call the most famous containerized technology, it helps the developer so that this container could be automated for in order that a container will be a portable one as well as lightweight one also. So if we can say that is a lightweight and standalone application. Whatever is required to run that application, all will be bundled together. And it, for example, if you're this is an ML model, whatever is required to test that ML model, all the libraries, system tools, all will be bundled together. So this is one example for a Docker file, image as well as container. So you can see this Docker file is used by the Docker to build this image. So wherever you want, you can export that image and you can run it up. So this image is run on to form a container where the application will be running. So you can say that container is like an instance. Suppose if you open 5 Word documents, so one is an instance. Likewise, this container will be an instance of an image. So next is we have seen like how to run a web service. So how we should do? So here you need to write down this code in your Python, where you can say you're using the version 3.6, and what you need to do, this app we are developing, right? App.run. So from this app should be moved on to the work directory, which we call it as deploy. Then to run this app, we need certain requirements. Those also we will be having, that should be under this deploy. The same thing, what we need to run, we need to run this model. So this model has to be copied onto the work directory deploy. Next, what we need to do, you need to install the requirements which are needed to run this model. So run pip install hyphen r requirements text. Now we are identifying the port number. So entry point is Python app.py. These are the requirements which we need to run. So once if it is developed, okay, next is you need to run the Docker by you need to type this to build the Docker image. So Docker build hyphen t app aromax social dot. So here this name is actually this social underscore trained is the model name which we have created. So using that you need to build a Docker image. So as soon as a Docker image is built, you can check whether the Docker images has been created or not with the repository. Then finally, what you can do, you can just check and you can execute that Docker image. So Docker run hyphen p. From that, you're running that app hyphen social. So suppose if you type this URL on the browser, you like we have a test case, hello world will be displayed. Once if it is displayed, you can check whether our Docker image is working or not. So you can just check by typing this command, you can see whether the test data is predicted or not. So this is how you can deploy a model, ML model onto the, you can see onto the cloud. Is it clear? Any doubts? Is it clear?
It's clear, ma'am.
Okay. Yeah. So this is how you are supposed to deploy a model onto the cloud. So next, so once now we have everything fine. So far, so good. Now what is our next motive? We need to host this Docker container onto the cloud, AWS EC2 instance. So for this, what I have done is I have created a account where I can host the web service. So whoever it is, they can use it. So by claiming that instance. So next, what we have done here, we need to host the web service onto the net. So for that, you can just click on get into the login, that is a AWS login account, and there you can check management console, and there we have easy to uh, instances. You just check for those in the search bar, and you need to move on to this easy to instance. Once if this is identified, Amazon EC2 resources, okay, elastic computing cloud. So this is a web service. As we are going trying to host the web service onto the net. So this is a web service which is provided by AWS. So what does this virtual server do? We are resizable. This EC2 will provide a resizable computing capacity, which we call it as instance. So users, you can choose what kind of instances you require. Suppose I want 60 GB RAM, then this much storage, this much computing power. So based on that, I can create a instance. Apart from that, as I told you, why we are going, because scalability, you can scale up and scale down the resources. And here whether you are going to work on any huge application, so there you can say that whether you need GPU power or CPU power, etc. And Amazon machine image is there, that we are going to see in the next few more slides. Here what is that Amazon machine images is, it is pre-configured Amazon machine images will be there, where it will include applications, operating system, as well as runtime environment also. And here pricing, based on your usage, pricing will be done. And we can say that load balancing also could be done. So here you can see what all the instances are running over here. how many instances are there, whether any load balancers are there, security groups. We can say that any inbound and outbound traffic instances which are applicable to this a particular instance you can see. And here key pairs are there. So we need to check on this key pairs because we require to run our model in the case of a web service. So either as we know that public and private, I'm not going to talk much about in detail about this. So like any you can say that this is like basic level security or an extra layer security for the cloud instance. So like credentials, not even like credentials, like a key where only that user will be authorized and he or she might be using this. So click on this key pairs. Once if key pair is available, as of now no key pairs are there with me, so it might be listed over there, you can check it out. So here if you download, you can say that ch mode because you need to provide only to the user. We have three groups like user, owner, and others will be there. So we only for user you are going to give the authorized access. So ch mode and privacy encryption mail PEM is there. So this file has to be downloaded and only that user will be accessing the corresponding file. We are trying to change the access rights. Once of the access rights is seen, next we can say that the instance has to be launched. So here you can give the name of the instance and you can say what kind of instance you are going to launch. Next you can see as I told you, AMI, Amazon Mission Image, where it consists of a bundle of configurations like OS, application server, everything will be there and you can check that also. So once I have created one and it has a name, ID will be there. What kind of architecture? I am checking out hyper virtual machine and these things. Because since we are going with free tier architecture, certain you can say certain things only will be available under free tier architecture. So here you can see what kind of instance you are using. If you are going for Windows, it is 0.01 USD per hour, like SUSE is there, Linux is there. So as of now, previously T2 was there. The T2, here we have T3 Nano, then we have T3 small, then we have T3, I think medium is also there. So we have used like nothing varying will be there. We can say that the price might be varying between T3 nano, T3 small, and T3 medium. So here the CPU performance. So what kind of how many cores you require, what is the memory you require, you can just identify and you can select it. Then what we need to do is next is you need to modify the security group. One option will be there. After this you need to modify that. Either you are going to, if you enable that only, you can look up onto the port number 80 so that the inbound and outbound traffics will be eligible to come in and walk in out. So once if it is enabled, and here you can use secured socket cell SSH into the easy to machine from our local system by this command. So what we are trying to do, I am trying to locate that privacy encryption mail and I'm going to give the name with our easy to. So here I have created a sample. um, yeah, I have created a sample. The instance name is sample and I'm trying to locate it with the DNS name. So what does it do is, there a prompt, as soon as this is working, a prompt will be raised where it will check for the Docker to be installed. So within the same instance. So using that, I'm trying to install my Docker also. So user mode will be changed and service will be started for that Docker to be initialized. So this is how you can do on a AW2 ECS. Once the instance is up, okay, you can see it will be showed in running mode. Like here, you can see instances running. You can see your instance will be up and it will be running. So you can just check how it is working and what all will be there. So how to check whether it is running or not? You can see whether the Docker is working over there. Docker info, if you give, you can just check it, and you can log out again and open another terminal window where you need to copy all the files that are required to build the Docker image within that sample instance. You need to do so. Here you're supposed to copy whatever it is, the file which we require, privacy encryption mail. Then we have this requirements text which we used for developing our ML model. So what all the requirements is required, app.py, what model, that social model, and along with the Docker file. All these things has to be copied, which is used to build the Docker file. Where we need to copy, where the sample instances, there we need to copy. How to copy? Just by locating the DNS name, and there all the files will be copied. So you can check whether all the files have been copied or not. Just if you click on the sample instance, the name is sample. Don't think that it is given. The instance which I have named as sample instance, where you can see all the files have been copied. So from the browser, you can check. See here, easy to instance. This ID will be there. Published are there. Yeah, some ID will be given. You can see that ID will be displayed over here along with the DNS name. And once if it is fine, your hello message will be displayed. So this is how you can find it out. Then next what you can do, you can request your web service from the local terminal where the sample data, what we need to check, some new data point. Okay, that should be passed on. But how it could be passed on? It should be passed on by the DNS name with the help of, because here this we have done in our local system, but this should be done on the DNS after replacing the public DNS name by our DNS name. Our DNS name is this one, sample at the rate of public hyphen DNS name. This should be given there to check. Once if it is done, we will get the class label for this data. Either the user is going to purchase or not. Once if everything is completed, then you can share this curl request. Whoever wants to test, they can test with this. They can send any data point for testing. So once if everything is fine, now you want to switch on, shut down this instance. In the sense, you need to shut down the instances and you can come out of this. So this is how you can host any Docker container and you can run any ML model onto the cloud. So far so good. So this is one instance which I have created and I have checked for this label data. You can ask what all the other cloud machine learning platforms which are available. So you can say that we have SageMaker, then another one is Azure Machine Learning, and we have many, but we'll be seeing few like Google Cloud Auto AML. So here, what does this AWS SageMaker does? You can see this belongs to AWS provider only. So here you can say this is a service which is used to simplify the process of building ML model, training the ML model, as well as deploying the ML model. So what does it do is you can say end to end connection. So end-to-end workflow is made possible with this end-to-end ML machine flow is possible. So here, what we do normally, we will have the data. So if the data requires labeling, we'll do that labeling techniques like a label encoder is there. Some pre-processing will be done. Then you will train the model. You need to validate the model, and you're supposed to deploy the model. That is end-to-end ML flow, starting from the initial stage and finally till the testing process. It will be done. Next, um, integrated Jupyter authoring notebook instance. You can say this SageMaker can integrate with the Jupyter notebooks. So what does it do is it has the ability to create a model as well as you can access the data sources for analysis. Here, no need of managing the server. Then common machine learning algorithms, whatever the algorithms which might be running, it could be or optimized so that it can host a big data and it could work or deploy in a distributed environment. Apart from that, we have like model training, which could be a customized one. So custom models could be trained using this SageMaker. Then native support for custom algorithms and frameworks. That's what I told you. Then quick deployment. Either you can use the console or studio, like it will be like user friendly, where it could be easy to deploy. Then paper usage. Then we have other services like uh, Amazon S3 for data storage, which is used to store the data. Then we have identity access management for access control, as well as we have serverless computing, which is recent one. AWS Lambda is there. So next is what does Azure do? We can just have a comparison also. If you are much interested, you can just check which one is like what does each do. So here Azure ML, Azure Machine Learning, where we can say this is a cloud-based platform which is provided by Azure. The same thing, it also used to create, train the model, deploy the models. Here also we have like integration, notebook integration is possible, AutoML is possible, where the process of AutoML means, see, suppose if you give the data set, any model you can deploy, but we should know which is the best model. So the models will be chosen automatically, and hyperparameter, which kind of parameter will be tuned for getting the best accuracy, that also could will be automized. And we have a visual interface called like a designer, where the models will be, you can say you can create, test and deploy, and you can with the help of drag and drop approach. Then we have open source machine learning framework support like a TensorFlow. Then we have PyTorch, etc., which could be useful for creating and facilitating the process. And here the much more important is managing MLOps. So you can say machine learning operating, um, or you can call it as functionalities. So you can say this is like operations where integration is made possible, and you can say this ML ops could be a broader context under this DevOps. You might have heard about DevOps, development and operations. The same thing, like which will be uh, using for creating and deploying the model. So here ML ops, what does it do is it focus the collaboration between all sorts of team. Either the team might be an ML engineers, or it can be an operations, where the communication will be established. Then it version control, it focus on version control also, whether what kind of changes has been established onto that ML code. Then we can say that CI/CD, continuous integration as well as continuous deployment is required. Because if you need to test that ML model, integration is also required as well as deployment is also required, where it should be a continuous process where MLOps influences the CI/CD concept. Then we have monitoring and management. Apart from this, we have containerization. As we talked about this container, Docker, etc. So what does it do is containerization technologies could be established, where you can develop or build a Docker like a bag which will have all the ML models onto it along with the dependencies. Just this container, what you can do is using orchestration tools like Kubernetes is there, which is used to manage the container. So that could be done. Scalability and resource management, nothing to discuss, because as the name itself gives you certain features. Then you can say what else is there, machine learning workflows right from beginning, that is from processing of the data till the model testing, all will be supported by resource management. So here one important point is, while deploying this ML models to compete, so to improvise, then they are concentrating. This ML ops has the uh, facility of focusing on the feedback loops in order to retrain and redevelop. That is what here, retraining and redeployment of models based on this feedback loops is also possible. Then we have this Google Cloud AutoML. So here Google Cloud AutoML makes the user to create custom all the three. Most probably it works from beginning end to end, but certain differences and similarities might be there. What all the notable features of AutoML over here? Now people, you might have heard this AutoML is been from 2000, hopefully I think somewhere around 20, I guess. Now it is coming up. We are knowing recently. So this Vertex AI, this unifies AutoML and AI platform, which is providing an user interface, an application program interface, which will be a good one, where you can influence the AutoML training as well as custom training also is made possible. Then we have AutoML tables also. So here you can say that you can say that it is basically designed, or you can call it as a table means, you can say that tabular data will be there, and you can develop a model which will work specifically for the structured data, because table means a structure is maintained only for those kind of tabular data you can work, and that we call it as an AutoML table. So here usually what happens is, when you're working on any model deployment, as I told, feature engineering is the important task. So if it is a structured data, what you will do, you will check whether the data values are all on the features, how the values are carried out, what kind of influence of each feature will be contributing towards this model, validation, etc. So next is video intelligence, providing multiple options where it can integrate machine learning video models in intelligence models onto websites and applications. And AutoML, natural language processing. Nowadays, we are hearing about this llama 2, GPT-3, GPT 3.5, etc., where ML models are customized for document classification, paraphrasing. AI detection tools are there, and you can check whether the person is talking, what is the tone, how emotions are being recognized. So these kind of AutoML natural language will, using this you can enhance the feature AutoML vision to classify images. So this is quite an interesting topic also. So now we will see, I have chosen Vertex AI among this, so that as we have seen, Vertex AI, this unifies AutoML as well as the AI platform, which is used to leverage the AutoML as well as training and customized training. So here we will see how this Vertex AI is working on. So this is a powerful tool, you can say, which comes under the Google Cloud Platform Services. So just how we can consider this for any text or audios or videos. You can, for handling large data sets, and if you want to process any huge data, what you can do is you can integrate a few services like BigQuery or Dataproc or Dataflow with this Vertex AI, so that it will take the data, process it, and machine learning also could be done on top of it. One use case, for example, see, suppose your institution has some website features. A contact form is being given. So what people will do during admission time, they'll fill it, and we will get lots and lots of messages daily. Some kind of action is required. So what we need to do, we need to just take the messages, and we need to check out what how it will be beneficial. So you need to analyze the messages, how it what kind of comments, either it is positive or it is negative, how we are going to signify that. Likewise, we will be categorizing those messages where it will help our business to grow, our institution to grow. Now a system is required over here. So, this comes under the topic of natural language processing, where you will identify, analyze the comments, and how it will be, whether they are raising a concern, or whether they are giving a complaint, or whether they are recommending our services, or any other information is required apart from on our website, or whether they need some appointment to meet our mentor or principal, etc. So a system could be established. This is one use case where you can use this Vertex AI. So how it could work? So as I told you here, specific outcome, we have certain labels. So you can say this could adopt a supervised learning, and the algorithm details as well as whatever training approaches. It could be varying, like since we have taken here a text, so it could be related to NLP model. So if you are taking some other domain, then it will be working on other details. So here machine learning has various categories where it will identify distinct problem, and based on the user constraints also it will work. So another use case is there. So suppose I want to develop a customized email program. So what is the email program is, like usually what happens, so whenever you people go and purchase somewhere, you will get during the offer times, you will get this much discount is there, you please visit us, or it is closing year ending period, dhamaka, this and that. So how they are identifying and categorizing the customers based on our details. So how, what kind of behavior they analyze, what kind of pattern they are finding out. So here it is to enhance the customer engagement. Obviously any business people need to increase their business. So how they can work on the customer engagement, not only by assigning some personas over there based on our behavior, spending habits, they need to develop. So for that, how they are going to categorize, because I might be interested in one thing, some might be interested in other, so they need to categorize and they need to send mails only for a few people. How it is possible? So here, suppose, see, so one might be interested in this shoes or shirts or whatever it is. So for when they have purchased, what brand, what category, what price. So what ML model will do is, these are all considered to be features. So if I'm going to purchase this, definitely I might purchase this. So what kind of combinations? So target is either I might come once again or not, 1 or 0. So based on what I'm going to work on. So my ML model, I can develop some 5 to 10 ML models by providing a combinations of like item ID, brand, category, then again price is there. So I'll take a few features in one model, 1 and 2 features in one model, 3 and 4 in another model. Likewise, I'll develop various permutations and combinations of ML model to check whether the customer will be coming in or not for the next purchase. So this is how I need to work on. So this instead of sitting and coding like, okay, I'm developing a random forest, I'm checking first feature and second feature, I'm just checking. Next, I am again checking another ensembling model and just trying. Instead of sitting and doing all this, what we can do is this Vertex AI. You can put various models and you can integrate with other cloud services if the data is huge, and you can check on which model will be best in doing that. So as I told you, the flexibility of construction and adjusting the target option. So what kind of target option, whether we can increase the price or we need to increase the category, or one category might be more sold, one category might be less sold. So like various combinations I can work on that. So the same concept I can apply on marketing scenario, where the features will be same, but diversified target predictions also could be done. So these are all examples. So how this Vertex AI could be used? So usual, this is quite common because everyone knows about machine learning workflow. How it will be is, you need to take the data. So you will collect the data. Then you need to divide the data set into training and testing sample. Then what you will do, you need to make the data ready for the model. So it should be properly formatted and labeled. Then you can check the parameters, build your model, evaluate. So whether we have properly trained the model and whether it will be how our model is. You need to review the metrics. Then you can go for deployment and predicting whether the model will be available for use. So here, this one is important. How you are evaluating the model. So model evaluation. So until now, everything is quite common. This is also common, but here we need to check how you can evaluate a model. So model evaluation metrics are there. First one is accuracy, error rate is there, precision is there, sensitivity, specificity, ROC curve, FN score, geometric mean. So here, accuracy is, you can say, true positive. What is true positive and true negative? If it is positive, you are identifying it as positive. If it is negative, you are identifying it as negative. Okay. So this gives you the overall efficiency of the classifier. So how far the model works, whether it is predicting properly or not. So this is how your accuracy works. The accuracy is important, but in few cases, you should consider other models also. Okay. So next is error rate, how it is giving or showing the error. So what is your classification error, whether it is working properly or not. Third one is precision. People will get confused between precision and recall. Okay. Okay. So here precision is how far the positive, you can say how far the data labels with the positive labels are working properly or not. So that we call it as precision. So you should remember this here. Precision works for positive, and here sensitivity, how it is identifying the positive values properly. Specificity, how it is identifying the negative values properly. How your classifier model, how your model is working. And here comes the combined metric of both sensitivity and specificity. ROC curve, region under curve. Because people, you can see many papers providing AOC curve, ROC curve, etc. So here the performance of the classification model, excuse me. So how it is working? So it is going to, you can say that we are going to plot this ROC curve. It will be like true positive against the false positive. Overall performance, it could be identified. Overall performance of a model could be identified. So this F1 score is there, which is a combination of precision as well as recall, then geometric mean, specificity and sensitivity in a single metric. So apart from this, you can say like ROC is a valuable, like you can say this is a precious tool in order to evaluate the binary classification model. So now, as I told you, Vertex AI. Next, as Vertex AI is good to, we have seen that using this you can deploy any ML model. Okay, which could be considered on Google Cloud Services. Right, it is good. But other question is, if your data is huge, then how it is going to handle? In that, as I told you, this Vertex AI could integrate with the other tools. So here you can use this BigQuery, you can integrate this BigQuery, and you can further enhance the process if your data is huge. So what we are trying to do is, if your data set is large, which contains some information, okay, then you can go with this integration of Vertex AI and BigQuery. So here, data exploration in BigQuery is, you're going to analyze the data set. How we are going to explore and analyze the data set? Based on this BigQuery SQL queries. So what kind of pattern it is being exhibited? What is the association you can get with the data? That is made possible with data exploration. Next, we can say that ML data set should be established. So how you can form a ML data set? The same BigQuery SQL, using that you can create a data set where you can retrieve the necessary features as well as the target variable. So you're going to work through the query only. You're using the query, you're going to extract the data from the entire data set. Once if the data set is ready, then what we are going to do? You're going to use this Vertex AI onto the data set, and you will model the you will train the model, and certain algorithms or preferences, if it is required, you will work on. Then you will evaluate the model, you can deploy the model, and you can utilize this BigQuery, mm, utilize this BigQuery to check out the inferences. We have deployed the model, but what we are going to infer from this integration, so that predictions can be generated directly with the BigQuery so that this workflow could be easily incorporated. Clear? So this is how you can find out the inferences from the BigQuery. Is it clear? Yes?
Yes, ma'am.
Any queries so far? Any queries?
Ma'am, can we get any simple big data to work with?
You want any data set?
Yes, ma'am.
Okay. I'll provide you. But yeah, it is available in net. No problem. I'll check and along with this slides, I'll provide you.
Okay, ma'am. Thank you, ma'am.
Yeah. Any other queries are there? Shall I?
Ma'am, no,
Yes.
ma'am. Continue, ma'am. It's continue to.
Okay. Okay. Thank you. So we have done until this. Now we'll see how this ML could be directly integrated into this BigQuery. So we are supposed to work on a model deployment service within this BigQuery. So with this BigQuery ML, as I told you here, you can see the second step. A data set itself will be created using this BigQuery SQL so that what all the features are required, you can just select along with the target variable. Then here there is no need to the main this thing is no need to worry about the infrastructure, just the data will be pushed on over here. As we are doing predictions, batch predictions in the ML model, the same thing applies here also. So why do we require this integration in this Vertex AI? See, usually what happens, any ML model will work, but this BigQuery ML is restricted, or you can say that it supports batch predictions. Batch means it can contain more number of predictions. To enable this online prediction, the approach is like you're supposed to train the model in BigQuery ML, and then you are going to deploy them onto the Vertex AI endpoints through this registry. So you can say that this, yeah, yes, okay. So here, the effectiveness of the model, how the efficiency of the model can be assessed is based on updates and continuous training. So here, Vertex AI provides MLOps tool, which is used to monitor automatically, and it will ensure the accuracy also. Through this Vertex AI pipelines, this integration will be how it is facilitated is using BigQuery operators. So each task, like we can call it as a job, where we can say each query, it will be involving the query within that pipeline. Apart from that, you can say monitoring is also possible. So how it is done? In what way? Then we need to see this is the pipeline, as I told you. A cloud storage, we have a document, a text document, which is considered to be raw, where from this cloud storage you are using this BigQuery, uh, which as I told you, this is a task or a job for creating a data set. Each query, you need to establish that query, run the query to create a data set. Then once the data set is created, what you're trying to do is you're going to extract the title, content, as well as the label using this data flow Python job operation. Then for this, you need to create a text embeddings. Text embeddings will be there where with a TF swivel model using that BigQuery job, you will generate the text embeddings, and it will be provided along with the target, where a classifier will be established over here in order to train with the BQML model. Then a model will be evaluated. Finally, it will be predicted. This is the Vertex AI pipeline where the data will be provided from the cloud storage. So now Vertex AI, similar to your ML model only. Your data is being extracted. Then what you're trying to do, if any pre-processing, like embedding is one kind of pre-processing technique only. So you're doing that, then training the model, evaluating the model, predicting the model. This is a normal workflow where it could be simulated with the Vertex AI. While BigQuery ML, what does it do is it provides the capabilities within the context of the BigQuery. See here, you can see BigQuery ML is being established. So here the use cases, it could be suitable. Vertex AI could be suitable for any kind of application. Either it could be image classification, or it could be recognition of image, and document processing also could be done. And this could be established, or these kind of operations could work on large data sets that are stored in the BigQuery. And BigQuery ML, you can say this will be user friendly for SQL users. And here Vertex AI also offers a quite extensive set of tools in order to work with machine learning environment. This is all about this Vertex AI versus BigQuery ML. So shall we go for a break? Yes, please. Okay.
Yes, ma'am, you can take break for 10 minutes.
Okay. Yeah.
Dear participants, we will be back in 10 minutes.
So welcome back. I'm sharing my screen. So we were talking about this pipeline, how BigQuery ML will be working. Am I audible and my screen is visible?
Yes, ma'am.
Yeah, thank you. So now suppose if there is any application, for example, you want to classify the text. Usually the projects will be like you will be scrapping tweets from Twitter or whatever it is, and you will identify whether it is positive or negative sentiment analysis. Some kind of any news classification it could be. So what you can do is you can just deploy TensorFlow or Keras. Then you can just check out with a BigQuery ML language and AutoML. So which one will be the best one? If you're going with whatever it is, this TensorFlow backend, you can develop any deep learning models and you can train it on Cloud ML engine. If you're going for BigQuery ML, here this will work most probably on the structured data, and you are supposed to create a data set where we have seen here extracting the content and word embeddings, everything will be using this Vertex AI you can do. And AutoML is another way. It depends which one you want to choose. Suppose if I want to integrate, as we have seen in this pipeline, how you can deploy this BigQuery ML for text classification. So how usually everyone knows the DDL TCL commands, where the same thing could be used over here. So what we are trying to do is you're going to create a model with the name, like whatever it is, advanced data or something, whatever you can give the name, and what options or what parameters you will be passing here is what kind of model you are going to deploy. So here, since it is a binary classification, you will be you can deploy any logistic regression model, or you can work with a naive base also. As of now, we have used logistic regression model and input label. Like you can see here, input label columns, source from where the source, from where the data is coming in. So the sources, you are extracting the data with extracted as, from where it is extracting the data. So here you're using some regular expression which should be of, like all regular expression in TOC, as well as you can see you might have used in flat. So what you're trying to do is here, uh, which starts with all the characters. Sorry, all the characters. Then comma should be there. Then we need to have any text followed by that. So you're going to take the column, text column, and what is the target if target is there. Apart from that, title where you are going to use this. Suppose if you are from which website you are taking, that source will be given. And here we have given the title as BigQuery Hacker News Stories. In this, the regular expression should be of this one. where it consists of some www, from that www dot something, you're going to scrap all the contents. Then what you're trying to do is length of the title. This title should be greater than 10. And here you'll be taking the first 5 words or first 10 words, etc. And you are supposed to split based on the title. Here first 5 words only we are considering. Source from GitHub I am taking, and source it could be New York Times, or source could be TechCrunch. Any public repository you can consider. From this you are taking, and you're splitting the words. First 5 words are considered here. So from the source, for example, select source words, like first word, second word, third word, likewise you are considering from this. And ML model, it has to predict, right? It has stored in this adv data.txt class. Suppose if it is JSON, you can just click on this JSON. Here, what we are trying to do is word one. I'm considering it as government, shutdown, leaves, workers, really. So this is 5 words we have considered. And based on New York Times, from the predicted source label, it is saying that probability is 48%. From GitHub, it is showing 26%. From TechCrunch, it is 25%. So from New York, it might be scrapped. This is how you can say that how a BigQuery ML could be used for text classification. So here it is quite convenient way for building the models which will work on structured or semi-structured data. So if you just check out the inferences when we integrate this BigQuery ML with Vertex AI or whatever it is, you can say that the assessment of ML model could be far more better, and it will be cost effective also. And here accuracy which could be achieved through this could be on assessed, how it could be assessed. So when you're developing or identifying a problem with a BigQuery ML, and if it is going to transform into AutoML, here, since AutoML, there is no need of manual coding. Just as I told you, it might be, suppose if there are, if it is a text classification, this using AutoML, what we can do is you will give logistic regression, support vector machine, naive base could be run. Among this, which gives the best accuracy could be identified. So these kind of text classification, and where the data is high, that is huge dimension, the dimensions may be many. AutoML could be a right choice where it could be giving you better performance. And you can say that if it is, since it is a structured data, you can use any embedding techniques also in general. So these were the inferences from this deploying this BigQuery ML for text classification. This is how it works. So now we have seen how to deploy an ML model and how it is handling, how the data providers support this big data analytics and machine learning. That we will see now. So what all the, what all the uh, functionalities, you can say functionalities on which cloud storage providers should work on in supporting both big data analytics and machine learning. First, you need to check on data format. So how this data format will be, what kind of format will be used, then how you can integrate the data. If you are using Google Cloud platform, or you might be using any other provider, how the data will be integrated, that we need to check on. Then security, how the storage provider is going to give security for the data. what kind of security practices they are going to establish. Either it could be a role based access control or it can be attribute based access control. What kind of security is being given for the data as well as for the model, what we are going to establish. Then finally, we need to check how it is visualized. What kind of visualization tools could be established. So these are the functionalities where the cloud storage providers can attract the customers. Here, next, if you talk about the challenges, what all the challenges you can work on. Few people might be enrolling themselves in various projects or something like that. So you can focus on how the distributed systems could be established for processing these kind of data. So distributed systems, you people might be handling how it is working on parallel processing. So, what all the research challenges for analyzing the big data and how this workload is being balanced. So, that is one kind of problem where we can focus. So, suppose if you take in this case, or in our case, how the data, if we are having huge data, it should be distributed and process should be established. So you can say a framework could be designed where we have seen in this case, as I told you, why you can develop various models where you can have a combinations of features, right? And the target predictions could be varying and you can check it out. So in that could be a use case for analyzing the big data and how this workload is being managed, so that you can work on. So this is one problem where you can focus. Then you can see like security, how this security could be established for the containers. So, as I told you, this container could be bundled with all, like it could be a model. Whatever required for that model will come along with that. You can see how this security could be provided for the container, how this container will work, and what is the load it could be handled. So, that could be another research area. Energy efficient machine learning model. So how we are going to work on this energy efficient, because as we are seeing, we are deploying few models onto the cloud, and we need to check how the architecture will be established, what will be the size of the model, how it will work on hardware devices when you are using GPU, what could be the processing power, how the energy will be maintained. And then you can say if you are going to use TPU and GPU, how it will maintain the efficiency, and if the models that could be deployed on IoT devices, because data transferring could be decreased and processing could be centralized, where the energy efficiency could be focused on those kind of devices, how it will work. So that could be another problem. And in this case, we can check out the resource allocation also. So suppose if you are need of any hardware, in order to save the energy, how this frequency as well as load could be provided to that resource. Then model compression techniques, how optimization could be established. So that could be another research area. Then we can say managing big data. So how your data will be managed. So for that we have storage. So Google Cloud Storage is there. So how we are going to handle that? What so you can use metadata management. So how we are going to process that metadata management? How you can establish that security for that metadata as well as data management? So what kind of file system could be established? and workloads, ML workloads, how it could be. So we have seen ML workloads. Then time series analysis and cloud. So you can say time series is like a share market is there. Huge data will be exported onto the cloud. Then what kind of analysis? If the distributed time series processing here also. So like you can design a framework in order to work on the large scale time series. Then scalable storage. So how you can effectively work on cost effective storage solutions. And processing, time series processing, how it could be done. Again here, what kind of AutoML model could be suggested? So what kind of framework could be suggested? Then suppose if any failure occurs during the processing, how the fault tolerance and reliability could be managed. So these could be the research challenges. So when we were talking about this MLOps, another research area, how can we compare this MLOps and DevOps, development and operations and machine learning operations? So how we see there is a combination of machine learning, DevOps, and data engineering also. So here, how this ML lifecycle could be streamlined. So we can say the in the process of streamlining, we can say the same as I told you: continuous integration and continuous deployment. How we are automating the testing, validation, as well as deployment could be done. So here, this you can see continuous integration as well as continuous deployment, how it is being established. You can see here the app developer is there. So he is developing some through an IDE, and some process has been done, and he is trying to put it in the repository. Either it can be GitHub repository or it can be Azure repository, whatever it is. So a data scientist who wants to use that using Jupyter Notebook, he can use the machine learning service from Azure and fetching the latest model from here, from the Azure pipeline. So usually this pipeline, how an ML model will be done. After building this, then they might release it. Then this could be stored in the container registry also, where you can access it. So this container service, as I told you, container means which where ML model along with other functionalities will be there. You can say that this container could be deployed. Container service could be deployed and hosting the deployed application. So, for example, a task of image classification is identified. So this could be run on mobile also. Just you can deploy that image and you can work on that. So whatever you do, like suppose if any changes are done, just you can just check out that container and you can work on that container where that will not have an impact anywhere. If any changes is being done, just right from the scratch, it is known there is no need to work on. That is the beauty of this CI and CD, continuous integration and continuous deployment. So here you can say this automated testing could be established along with the version control. So what all the benefits are there is error reduction will be very less. And here you can see Jenkins are there, GitLab is there, Travis is there, which can these are the tools which are used to CI/CD. And Docker and Kubernetes, here you might have used this. All these are considered to be containerization and orchestration tools where this Kubernetes is used to deploy the corresponding container application. So if you talk about this ML pipeline, data ingestion should be there, validation of the data, then you will be pre-processing the data, model training will be established, then analysis and validation, model deployment. So as I told you, this feedback loop, in the beginning of this FTP, I have talked about this feedback loop. Based on that, you can do something, like do some modifications in that. So this you can call it as pipeline orchestration, where this could be provided as a container image also. So here, this orchestration, pipeline orchestration can be of various types based on the role. So if it is a model, you can see like model itself could be done, data orchestration could be done, and code level orchestration also could be done. So if you are working on code level orchestration, this CI/CD will come into the picture. If you are working on model orchestration, this model training, model analysis will be coming into the picture. And if you're working on data orchestration, you will be focused on data. So model orchestration is right from here, excuse me, data ingestion, data validation from here till the deployment. So here you can say that reusability is, excuse me, possible, where in the case of data orchestration, it will be focused on data centric activities. And in the case of code, you can say that code Jenkins could be used. Open source software is Jenkins, where it could be used. Here you will be using Kubeflow, and Apache Airflow could be used for data orchestration. In the case of code and app orchestration, you can say that using the code that is a model, you're going to develop that as a service or an app. It could be a web service or web application. These kind of orchestrations are possible. So if you say deployment, so once you have used this model orchestration, how you are going to deploy it? So what kind of model you have done? So I have used logistic regression, I'll say. Then the starting stage pre-processing should be done. So pre-processing pipeline, either it could be label encoding or one hot encoding, etc. Next, we are checking whether the data is numerical or categorical. We are just developing into a bundle. So if it is numerical value, what should be done? If it is categorical value, what should be done? Then any other technique, standard scalar, min-max scalar are there. As I told you, one hot encoding or label encoding is there. So here, based on the data, you should use either one hot or label encoding. After that, you are applying clustering techniques or dimensionality reduction could be done. Then logistic regression is applied. So this we can call it as a pipeline for deploying. You will be just deploying this. So if you give a data set, what will happen is it will do all the process. And you can do one application here. See, you might not know what the data set might consist of, what features might be there. It could be numerical as well as categorical values. So if there is numerical value by default, like standard scalar or min-max scalar, how that analysis could be done? Then either you're going to use how many features are there and how many features belong to numerical and how many features belong to categorical. So likewise, you can just work on and you can deploy an AutoML for that. Then container, how a container could be, as we are talking about container and Docker over here. Everyone might have seen this is a virtual machine where this is the underlying infrastructure which we might be use, and on top of that we will be having hypervisor. You can see the difference between the virtual machine and the container here. Container is like you can say here a container engine is there, where the operating system here will be shared by all the apps. Whereas in this case, each virtual machine will be having operating system, which could be used by its other VMs. But here, this container will be shared. So this image will be deployed. So this is what we are doing here. This could be a container also. This container will be lying on here. So next is like how it will be in a traditional deployment. Hardware will be there, OS will be there, libraries and frameworks will be there, apps will be on top of it. In a virtualized, like in VMware, you can say that virtual machine, like one could share one operating system, another VM could share another operating system, etc. But here, container is considered to be a bundle where all the packages which are required, any libraries are required, any dependencies are required for running that app, that could be coming in a bundle. If I want to develop a container, then you can use the Docker as a software in order to build and manage the container. And you can say, if I want to manage the container, you can go with Kubernetes apart from Docker also in a clustered environment. So you can see this container applications, how many Dockers are working, how many Docker and container will be more or less nowadays they are making it as one and the same. How it could deploy and how it could be managed, and which Docker is running, which container is running. You can work on this security also. This is very good and interesting also, but it might be quite complex. But the problem is, the thing is, what you can do is, if you want to do that in a gateway or in a host or in a firewall, you can establish any security like a watchdog, so that it can check out and provide the solutions also. So these are my references from which I have taken. Any queries? Any queries?
Yes, ma'am.
Yeah.
Can we get any sample big data to work with, ma'am?
Yeah, sure. I'll check with along with my slide. I'll share it. You can create a online. Let me show you. See, is my screen visible?
Yes, ma'am.
Yeah. See, if you want to generate any sample data, as I told you, like any activities on the website. So, because you can say that a huge data might be generated. That is one way. You can have any tool to just watch out all the activities on a website, and you can put it on a data set and you can work on that. Other ways, I'll share it. One data set I have, you can work on that also.
Okay,
So
ma'am.
this is how, as I told you, instances, how to create a launch an instance. So you can see here, if you want to launch any instance, as I told you, name and tags will be there. On whether you are going to work on Mac OS or Ubuntu or Windows, you can give Amazon machine ID. And here, as I told you, instance type could be given. Key pair. As of now, we don't have any key pair, so you can just check out network settings. Whether if you just enable this only, as I told you, like it could allow the traffic whichever is coming in. If you want, you can configure, how much the storage you require. Then you can launch the instance. And then once if it is working, I told you just you can deploy any ML model onto this and you can check it out. Any other doubts?
Ma'am, another doubt, ma'am. Can you give example for time series analysis, ma'am?
Time series analysis in cloud. You're checking, or normally you have a like a floating share market, or you can just check a stock prediction. See, suppose you can say uh, the gold price over here in India, and how about in other countries. That we call it as floating. Some name is there, that you can check it out. Then here, time series analysis. So within this particular session, how many are accessing that user activities could be done. That also you can just check on. How many are attacking attacks and threats. You can take that also as an example.
Thank you, ma'am.
Yeah, welcome. Any other queries?
Yeah, ma'am. One more, ma'am. What are the data recovery techniques applied to cloud, ma'am?
That is huge. You can just we have certain algorithms also. Tools are also there which are available. You can just check on, like for example, regular backup. How snapshotting is there. Just take a picture and you can check out. If you're checking on cloud-based recovery, just you can write code in such a way that every 15 days or every 20 days a backup, or every day backup, every hour backup should be done. Likewise, you can work it out. And how it is going to be managed. If it is working on distributed data, how you are going to replica the data. As it is spanned across multiple and availability zones, we should ensure the redundancy also. So how it is working on. Likewise, you can just include certain features, and tools are also available. You can just check out the tools also.
Okay, ma'am. Thank you, ma'am.
Yes.
And I would like to express my sincere gratitude to Sumati ma'am for an insightful session. Your expertise and engaging delivery have provided us, the participants, with a deeper understanding of these technologies. Thank you, Sumati ma'am, for your valuable insights and for making this session an enriching experience. Thank you, ma'am. Thank you once again.
Yeah, thank you. And you can see in AWS itself, as I told you, we have an instant startup. We have likewise we have backup also. You can just use that also.
Okay, ma'am. Sure.
Yeah. Thank you all.
Thank you, ma'am.
Shall I leave the session?
Yes, ma'am. Thank you, ma'am.
Thank you.
So, dear participants, we have posted the feedback link of day 2 in the live chat box. Kindly fill the form. And about the PPTs, we will be sharing by the end of the FDP, that is by Monday. After Saturday, we're going to finish, and then Monday we will be sharing the all the PPT. Thank you.